So in chapter 9, we will introduce the concept of linear momentum, and we will discuss later on the collisions. The concept of linear momentum is very useful to describe objects in motion. In particular, think about two objects or two particles, one light particle and one heavy particle, both moving with the same speed v. Now, the only variable that we can use to distinguish between these two particles, the motion of these two particles, is the kinetic energy. Because the kinetic energy, you have the product between the mass and the squared of the speed. But the problem is that the kinetic energy is a scalar quantity, which means it's just a number. It's not a vector, and it doesn't provide any information about the direction in which each particle is moving. This is why the linear momentum is important concept to be introduced. And the second point, why is it important? Because it leads to a new conservation law. We have seen in chapter 8 in particular, the principle of conservation of mechanical energy, in particular for isolated system, and the principle of conservation of energy in general, how much they are useful in solving problems where we deal with different type and forms of energy. So let's start with the first section. It's called linear momentum and its conservation. So in this section, we're going to consider an isolated system, and we're going to work in this isolated system to identify the expression of the linear momentum and what does it mean to be conserved. So let's consider an isolated system made of two particles, M1 and M2 of masses, يعني M1 and M2, and moving with respective velocities V1 and V2. So V1 is the vector velocity of M1, and V2 is the vector velocity of M2. And of course, these velocities, they correspond to the velocities of the particles at a given amount of time. So if you look at this system, you will end up with this is M1, this is M2, and each of these particles is moving with a given speed. So let's say this is moving with V1 and this is moving with V2. So at the moment, the directions of V1 and V2, they are not important. We are just considering them as they are in arbitrary direction. The most important thing is that the system is isolated. So since the system is isolated, هذا الشيء شو بيعني؟ يعني إذا كأنه بنعمل imaginary boundary between the system and the environment, and the external environment. An isolated system means that there is no exchange of energy between the system and the external surrounding. So there is no exchange of energy, and so therefore that means that there are no external forces acting on this system. So if we look at the particle M1, we can say that the only force acting on the particle M1 is that exerted by M2. So the only force acting on one is the force exerted by 2, which we call it F21. And in a similar way, if you have a look at M2, you will see that the only force acting on M2 is the force exerted by the particle 1. So this is why we call it F12. And as you all know from Newton's third law, that if you have two particles and one is exerting a force F21 on the second, then the second exerts a force F12 on the first, F21 on the first. However, these two forces, they have the same magnitude, the same modulus, but they have different directions. So from Newton's second law, we can write down F21, the force exerted by 2 on 1, is equal to minus F12, the force exerted by 1 on 2. So this corresponds to an action-reaction pair, where the modulus of F21 is equal to the modulus of F12, and the minus sign, it tells us that their directions are opposite. So from this expression, we can write down F21 plus F12 is equal to 0 very easily. Now, if we apply Newton's second law, so Newton's second law on M1, what does it tell us? We know from Newton's second law, if we apply it on a given object, it tells us that the sum of external forces, or what we call F net, is equal to MA. But in this case, the summation of all forces acting on the mass M1, it's nothing else than F21, ما في غير فورس وحده عم تعمل اكشن على البارتيكل 1. فاذا F21 is equal to m1 times a1. And a similar way, if you apply Newton's second law on m2, you will find that the only force acting on it, F12, is equal to m2 times a2. So by taking this expression from Newton's second law, we will find out that m1a1 plus m2a2 is equal to 0. And if we use the definition of the acceleration, which is given by a as the derivative of the velocity vector with respect to time, you will end up with this equation, m1 dv1 dt plus m2 dv dt is equal to 0. Now, since we are dealing with these particles, and for particles the masses are constant, and since the derivative of the mass with respect to time is 0, we can get these masses inside of the derivative. So in other words, if we make the derivative with respect to time of m times v, what do we end up with? So we end up with, first of all, the derivative of the first variable multiplied by the second plus the first variable multiplied by the derivative of the second. بس ما انه الماس هون is constant, so that means the derivative of the mass is 0, and so we end up with m derivative of the velocity with respect to time. So we can ما انه هيدي derivative m times dv dt هي نفس derivative ل m times v كلها, so we can get this mass m1 inside of the derivative, m2 inside of the derivative. We are allowed to do so because derivative of mass with respect to time is equal to 0, and so we end up with this expression. And so we can write it in this way: the derivative with respect to time of the sum m1 v1 plus m2 v2 is equal to 0. Now, as you all know, if you have a derivative of a given expression with respect to time that is equal to 0, that means that the expression that you have, which is x here, it does not depend on the time. And if it does not depend on the time, that means that it is constant. At any time you are looking at x, you will find it all the time the same because it's constant. So that allows us to say that the summation, the sum m1 v1 plus m2 v2 is constant. It does not vary as a function of time, and therefore we can define m times v to be the linear momentum of a given particle. So if we say that p is the linear momentum of the particle, then we can say that p1 is equal to m1 v1. Then m2 v2 would be the linear momentum of the second particle, that is m2 v2. And so the expression that we have in here inside the derivative would be p total, or p of the system, which is the summation of the linear momentum of both particles. So p total is equal to p1 plus p2. And from here we can deduce that the linear momentum of the system of the two particles is conserved if you have if the system is isolated. يعني, or in other words, the linear momentum of any isolated system is conserved. So from here comes the definition of the linear momentum as the product between the mass and the velocity. And here again, you can see clearly that if you have two particles, one light particle and one heavy particle, إذا بنطلع على الفي ما بنقدر نشوف أي هي الأثقل ولا أي هي الأخف، وإنما إذا بنطلع على linear momentum دغري بنعرف which particle is the heaviest and which particle is the lightest. One aside comment, the unit of P is given by kilogram meter per second, so it's the unit of the mass multiplied by the unit of the velocity. And also you should keep in mind that the direction of the linear momentum of the vector P is the same as the direction of V. لأنه هون ال P وال V they are proportional. However, their coefficient of proportionality هي عبارة عن الM، والM هي it's a positive scalar، يعني هي عبارة عن رقم اللي هو على طول بيكون positive، ما لها معنى إنه الماس تكون negative. So, can we find now a relation? Can we find a relation between the momentum, linear momentum P, and the forces acting on the system? Let's try to do so. So according to Newton's second law, we can always write that the net force, the force exerted, the total force exerted on a given system, it's given by the mass multiplied by the acceleration. So in this case, let's take the case of a particle بكل بساطة. So F net is equal to ma, and since a, it's nothing else than the derivative of the velocity with respect to time, then we can write this expression as the derivative with respect to time of mv, as we have seen previously. And according to our new definition, this mv is nothing else than the linear momentum. So at the end, we end up with this expression where F net is equal to the derivative of p with respect to time. So in words, the time rate of change of the linear momentum of a particle is equal to the net force acting on the particle. أو بمعنى آخر, if you have a particle that is moving with a given linear momentum p, then this it will remain and it will continue moving with the same linear momentum p unless it experiences an external net force. اللي هي equivalent لنيوتن's first law in terms of the sense of this equation. وكمان هي equivalent لنيوتن's second law. So we can say always that F net is equals dp dt is an alternative form of Newton's second law in its classic form اللي هي given by F net equals ma. So هون بهالحالة بنحكي عن نفس الشيء، هي كمان هيدي نيوتن's second law, but it's a more general form of Newton's second law. Why? Because if we have, for example, a system in which we have variation in the mass, then when you say F net is equal to the derivative of the momentum with respect to time, where p is the momentum of the linear momentum of the system, then this yields the derivative of the mass with respect to time multiplied by the vector v plus the mass multiplied by the derivative of the vector v with respect to time. And so if the mass of the system is varying, then in this equation you take this variation into account, while in the case of a Newton's second law, in this case it's a more particular case where you cannot consider the situations where the mass of the system is varying. example كتير بسيط عن هيدا السيستم. for example شاحنة ماشية على الطريق محملة رمل وفي مكان ما leaking، ففي تسريب بمكان ما للرمل، فالرمل عم ينزل طالما الشاحنة عم تمشي. بهالحالة بصير في variation للماس للشاحنة لأنه الرمل هو جزء من الشاحنة، وبالتالي إذا كان عم بينقص مع الوقت، الماس كمان عم تنقص مع الوقت. Voilà. So let's continue now and let's get back to our problem. So using the definition of the momentum and back to the isolated system of two particles, then the equation derivative with respect to time of m1 plus m1 v1 plus m2 v2 can be written now as, in terms of the linear momentum, as the derivative with respect to time of p1 plus p2 vectors. And since the derivative of this p1 plus p2 is equal to 0, that means that p1 plus p2 is constant. This summation is constant, and we say that the linear momentum is conserved. So equivalently, we can write down p total is constant, where p total is the summation of the linear momentum of every particle in the system. And when we say that is equal to a constant, that means if we look at any two times, let's say at initial time ti and final time tf, we will find that p at initial time ti is equal to the linear momentum at a final time tf. So in other words, we can write down that p initial is equal to p final. And what does it correspond to p initial? P initial, it corresponds to p1 initial plus p2 initial, because in our system we have two particles. And so this is equal to p final in the same way. It's p1 plus p2, and since they are in the final state, we have to specify that it is final. So p1 final plus p2 final, which means finally that the linear momentum, the total linear momentum of an isolated system is equal at all time to its initial value. So this is it about the linear momentum. Now let's move to the collisions. The collision is a very particular application for the conservation of linear momentum. And in general, the collision exists in our everyday life in different forms. So what is a collision? A collision is defined as an event in which or during which two particles they come close to each other and interact by means of forces. So like for example, you have two balls. These balls, they come very close to each other, they get in contact, and then something happens between them. There is an exchange of forces. For example, if you have a particle that is the electron, if you have an electron and an electron, then also these particles, when they come close to each other, they come close to each other from both sides. When they will feel the interaction between each other, when they exchange the force, they will be separated لأنه في repulsion بيناتهم. So this is what it means. What means a collision. And these forces that exist in a given collision, it could be of any type. So it could be a contact force, electromagnetic force, nuclear force, any type of force that we have previously seen. So we can actually classify any collision into mainly two types of collision, elastic and inelastic. All that depends on the conservation of kinetic energy in the collision. So a collision is said to be elastic if the total kinetic energy of the system is conserved before and after the collision, while a collision is said to be inelastic if the total kinetic energy of the system is not conserved. Yani, in other terms, it's not the same before and after the collision, a given collision. And we should also make one comment in here is that in the case of inelastic collision, there is different degrees for the inelasticity of the collision. يعني ممكن تكون inelastic بدرجات، وبهالدرجات ممكن في minimal وفي maximum. لما تكون loss of the kinetic energy, loss in the kinetic energy maximum، ساعتها بنسميها perfectly inelastic collision. فبهالحالة بنكون وصلنا للدرجة الماكسيمم. And whenever you are dealing with an elastic collision, you can always write down that K initial is equal to K final, while in the case of elastic collision, you can always write down that K initial is equal to K final. And this is why in elastic collision, you have always two conservation laws, the conservation of linear momentum and the conservation of kinetic energy. While in the case of inelastic collision, you only have conservation of linear momentum because the kinetic energy is not any longer conserved. This is it. I just want to make one more comment, is that in our real life, before, in inelastic collision, the loss in kinetic energy, it always appears in a different form of energy, like in the sound, heat, deformation. مثلا لما يكون في عندكم سيارة وهالسيارة خبطت بشيء، عملت اكسيدنت على الطريق، اول شيء بتسمعوا صوت، وبعدين بتشوفوا بعينكم انه في ديفورميشن، بتشوفوا انه انتعجت السياره او انتعج الباب الى اخره. الصوت يلي سمعتوه وهالشيء اللي الديفورميشن يلي شفتوها هي عباره عن كاينتيك انرجي تحولت لشكل من الاشكال اللي هي الساوند او الديفورميشن etc. So this is number one. Number two, in our real life بحياتنا العمليه والواقعيه ما في شيء اسمه perfectly elastic collision. يعني حتى نحن in our description in the course we say that collision between طابات البليار هي عبارة عن elastic collision، لأنه in this collision you don't have deformation of the balls, but all what happens إنه هالballs بيجوا they come close to each other, they contact each other، وبعدين بيروحوا بسرعات مختلفة. يعني they come in with initial velocities and they come out of the collision with different final velocities، بس ما بيتغير شكلهم، بضلهم intact، يعني ما بيصير في deformation لولا وحده من الطابات. بس بالفعل هي منا elastic collision، هي inelastic collision، لانه بس يجوا طابات البليار ويعملوا collision مع بعض وانتم بتسمعوا صوت كثير خفيف ودغري بتعرفوا انه صار في collision بيناتهم، فهذا الصوت هو نتيجه loss in the kinetic energy. فبالحقيقه هيدي collision is not elastic, it's inelastic. However الصوت اللي بتسمعوه ناتج عن loss in the kinetic energy which is quite small. This loss in the kinetic energy is negligible in such a way that we can assume that this collision is elastic. Okay? So this is it. What you need to know from this section is that in elastic collision, you have two equations, conservation of the linear momentum and conservation of kinetic energy. While when you are dealing with inelastic collision, بس بيكون في عنا conservation of linear momentum. Full stop. Let's start with a perfectly inelastic collision. So هدفنا هلا هون بهدول التو بارتس. باول بارت رح نحكي عن perfectly inelastic collision, and the second part رح نحكي عن elastic collision. So our goal in these two kind of exercises is to determine the velocity of the two interacting particles after the collision. So let's consider two particles, m1 and m2. Both are moving with the initial velocities v1 initial and v2 initial, and they enter into collision. هلا هون انا رسمتهم ال v1i وال v2i بشكل عشوائي، يعني مش بالضروره يكونوا جايين head on، ممكن يكونوا غير هيدي الرسمه. So let's consider then two particles m1 and m2 moving with v1i and v2i. When you have a perfectly inelastic collision, what happens is that these two particles, they will stick to each other and they will be moving together in the final state with a final speed or final velocity v final. So what is the value of v final and what is the direction of v final? We can determine it using the conservation of linear momentum. In this case, we are dealing with two particles in an isolated system, and so we have conservation of linear momentum. So therefore, Pi is equal to Pf, where the word I, it means that we are dealing with the time where we have before the collision. So هون ال I معناتها before collision, وال F معناتها after collision. هلا ايمتى before وايمتى after دغري، يعني لما نقول P before is equal to P after, that means P right before the collision is equal to P right after the collision. يعني بمجرد قبل ما تصير وبمجرد بعد ما صارت. ما بننطر كثير. Okay, what is the value of P initial? It's P1 initial plus P2 initial, and P final is equal to P final. تركتها مثل ما هي لأنه هون two objects they are moving together. So we can write down m1 v1i plus m2 v2i is equal to m1 plus m2 v final. هلا هون بهيدي السطر اللي وراه أنا I dropped the vectors. بمعنى آخر I dropped the vectors لحتى أقول إنه هدول الvalues اللي شايفينهم بهالequation they are the projection of the vectors along the a given axis. So for example, you can take in here this x-axis conventionally to the right to be the axis where to project the velocities. بس ما حطيت plus or minus لأنه we are considering the general case. يعني أنا هون ممكن يكونوا ال v1i وال v2i بهالشكل بس ممكن يكونوا بشكل مختلف. فما حطيت projection لهذا الكيس تحديدا، وإنما you have to remember that these v1i, v2i, and vf they are the projection of the velocities onto a given axis. And so from here we can deduce simply that v final is m1 v1i plus m2 v2i divided by m1 plus m2. And so knowing v1i and v2i, you can deduce v final. So this is it. For a perfectly inelastic collision, this is the only equation that we have and that provide us with all the information we need about what do we have in the final state. Now let's consider the case of elastic collision. In the case of elastic collision, again, let's consider two particles, m1 and m2, moving with initial velocities v1 initial and v2 initial. And right after the collision, they move with final velocities v1f and v2f. So in this case, our goal is to determine v1 final and v2 final. So this is why we are going to apply the conservation of linear momentum and kinetic energy. So let's start with the first one. Conservation of linear momentum, it says m1 v1i plus m2 v2i is equal to m1 v1f plus m2 v2f. So P initial, يعني ال P تبع السيستم initial هي equal لل P of the system in the final state. And so we can write down P1 initial plus P2 initial is equal to P1 final plus P2 final. حطينا كل واحد بقيمته. ال P1 initial هي عبارة عن M1 V1 initial, P2 initial هي M2 V2 initial. نفس الشيء بالنسبة لل P1 final and P2 final. And for the second one, K initial equal to F equals K final. You can write down simply the kinetic energy for both particles as we know in the initial state and in the final state. So we get this equation. Now, of course, you can get rid of the half in all the terms because it's present in all terms. هيدا رقم واحد. رقم اثنين. So let's actually try to manipulate a little bit this equation بشكل إنه خلينا نحط كل شيء which has a common factor مع بعضهم. يعني for example v1i squared, v1 final squared, they both are multiplied with m1. So let's put them together. We end up with m1 v1i squared minus v1 initial squared لأنه v1 initial squared صارت on the right hand side of the equation is equal to m2 v2 final squared بتضل هون بس كان بدنا نجيب هيدا الترم لتاني جهة so بصير minus v2 initial squared. So هون ما ننسى انه it has the form a squared minus b squared ومثل ما بنعرف انه ال a squared minus b squared هي a minus b a plus b. So let's write down this in this form. We end up with m1 v1 initial plus v1 final v1 initial minus v1 final equals m2 v2 final minus v2 initial v2 final plus v2 initial. طيب وصلنا لهالايكويشن. Now بقى بعد اللي فات في شيء ما استخدمناه هي الايكويشن 1. الايكويشن 1 اللي ما استخدمناه هو انه بعدها مكتوبه بهالطريقه. خلينا نكتبها بنفس الطريقه اللي كتبنا فيها الايكويشن 2. So بيطلع معنا من هون الm1 اذا بحطه in factor we end up with v1i في هون term m1 v1f رح نجيبه لهي الجهه بصير minus v1f right is equal to فاذا هون اثنين راحوا. خلينا نوصل على هون بيطلع عنا m2 في عنا v2f من هون وبانه هذا الترم ثاني جهه بنجيبه لهون بصير minus v2i. So ال1 نقدر نكتبها بهالشكل هيدا. طيب خلينا نسمي هالايكويشن 2 هيدا الايكويشن 3. اذا بنجي بنقسمهم على بعضهم شو بيطلع معنا؟ بيطلع معنا انه الm1 يعني اول جهه بتنقصي مع اول جهه وثاني جهه بتقسموا مع ثاني جهه. So بيطلع معكم m1 v1 initial plus v1 final بعدين v1 initial minus v1 final is equal to m2 multiplied by v2 initial minus v2 final و v2 initial plus v2 final. طيب بس بنقسمها على 3 اول وحده بنجي بنقسمها على m1 v1 initial minus v1 final وثاني وحده بنقسمها على m2 v2 final minus v2 initial. طيب اول شيء الm1 والm1 بيروحوا مع بعضهم. هون ال v1 initial minus v1 final بروح مع ال v1 initial minus v1 final وبنفس الشيء من ثاني جهه الm2 مع الm2 بيروحوا والماينس او السبستراكشن تيرم كمان بيروحوا مع بعضهم. فما بيبقى معنا غير التيرم اللي فيهم addition يعني ال v1 initial plus v1 final equals ل v2 initial plus v2 final. And now if you put back this equation اذا بنحط هيدي بقلب ال1 شو بيطلع معنا؟ يعني الايكويشن نمبر 1 شو في قلنا فيها m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 هي بدل هيدي في v2 final بدل هون كان في عنا v2 final. طيب بهالايكويشن المشكله انه حيكون في عنا تو unknown ال v1 final وال v2 final. خلينا نكتب ال v2 final in terms of v1 final هيك ما بصفي عنا غير بس one unknown. فاذا نطلع على هالايكويشن نمبر 4 بنقدر نكتب ال v2 final in terms of v1 final in the following way. It's v1 initial plus v1 final minus v2 initial. ال v2 final هي هاي sum minus هيدا الفاكتور بناخده لهون. سو هذا الشيء اللي عملناه حطيناها بقيمتها. بقى باقي ما تبقى هو بس عباره عن شويه كالكوليشن. الام 1 هون في عندنا الفي 1 انرجي هي ان فاكتور بهيدا الترم هون وبهيدا الترم. سو بيطلع معنا ام 1 ماينس ام 2 ام 1 ماينس ام 2 في 1 اي بيروحوا. هون في عندنا ام 2 في 2 اي وفي عندنا ماينس ام 2 في 2 اي. بنجيبها لهي الجهه الماينس ام 2 بتصير بلس فبصير في عندنا بلس ام 2 في 2 اي وهون بيبقى عندنا m1 plus m2 v1 final. So we end up with v1 final equals m1 minus m2 divided by m1 plus m2 v1i plus 2m2 over m1 plus m2 v2i. And in the same way, we end up with v2 final as 2m1 over m1 plus m2 v2 v1i plus m2 minus m1 divided by m1 plus m2 v2i. And as I told you in the lecture, well, it's better to remember or to memorize these expressions because if you need them, their derivation takes some time. So it's better to memorize them than to make every time you need them all the whole derivation. Now let's just have a look at some particular cases. The first case is when m1 is equal to m2. طيب لما يكونوا الطابات جايين like مثل بحالة البليار الطابات هن identical they have the same masses so what happens in this case when they make an elastic collision what happens is that ال M1 minus M2 بصفروا بالحالتين وهيدا الريشيو هون وكمان تاني جهة actually بصير في عنا هون 2M لنقول M1 is equal to M2 is equal to M بصير في عندي 2M divided by 2M so هيدول الترمز بصيروا 1 وبالتالي بيطلع عنا انه V1 final is equal to V2 initial and V2 initial is equal to V1 final يعني اللي بصير عمليا انه الطابة الأولى بعد الكوليجن بتاخد السبيد تبع أول طابة والطابة الثانية بتاخد السبيد تبع أول طابة دونك عمليا اللي بصير انه we have exchange of velocities between the two particles. This is the first case. Now the second case, what happens if you have one particle that is stationary? إذا كانت وحدة من البارتيكلز at rest. Like for example, let's take the particle 2 to be at rest. شو بصير بهالحالة؟ Let's have a look. طيب أول شيء إذا كانت البارتيكل الثانية at rest يعني بهالإيكويشن هون صار في عنا ال V2I صفر وهون كمان صار في عنا ال V2I صفر ما بيبقى عنا غير ال V1 final is equal to M1 minus M2 over M1 plus M2 V1I وبالنسبة للثانية بصير في عنا 2M1 over M1 plus M2 V1I. So these would become the expression for V1 initial and V2 initial. Now let's consider two cases بقلب هيدا الكيس. أول كيس في حال كانت الطابة اللي جاية اللي ماشية هي الكبيرة والطابة الصغيرة هي اللي واقفة يعني M1 is quite larger than M2 هذا الشيء بيعني إنه M2 over M1 is quite smaller than 1 يعني we can say that M2 over M1 converges to 0 أو tends to 0 then بهالحالة فينا نقسم بال V1F وبال V2F على M1 بالنيوميريتور وبالدينومينيتور فما بيبقى عندنا غير 1 minus M2 over M1 divided by 1 plus M2 over M1 V1I بما انه هدول two terms they are very small so they could be neglected in front of 1 لانه هن كثير صغار بالنسبه لل1 and so we can write down that V1F is approximately equal to V1I اما بالنسبه للحاله الثانيه فبصير في عندنا هي 2 M1 over M1 بتصير 1 تحت 1 زائد M2 over M1 ف times V1I so it's approximately equal to 2 times V1I so اللي بيصير هون انه اذا كانت particle M1 جايه ب V1 initial والparticle M2 هي at rest with V2I equals to 0 so with V2I equals 0 اللي بيصير بعد الكوليجن انه ال M1 بتضلها ماشي تقريبا بنفس السبيد تبعولها وكأنه شيئا لم يكن اما الطابة الثانية بتمشي بسبيد which is twice the value of V1I. Now what happens if it's the opposite case يعني شو بصير اذا كانت ال M2 كثير اكبر من M1 فبهالحالة بينقلب الشغله يعني M1 over M2 هي اللي بتصير quite smaller than 1 وبالتالي we can neglect it in front of 1 so بهالحالة بالاكسبريشنز لل V1 final وال V2 final اللي هون اساسيات حنقسم على M2 اذا قسمنا على M2 بيطلع معنا M1 over M2 divided by minus 1 divided by M1 over M2 plus 1 ال M1 over M2 it's very small compared to 1 فبيبقى عندنا هون minus V1I وال V2F كمان عم نقسم على M2 بصير هيدي approximately equal to 0 so this is approximately equal to 0 so بهالحالة إذا كانت البارتيكل stationary هي الكبيرة وهي الثقيلة اللي بصير إنه إذا إجت عليها طابة أصغر منها بكتير حجماً و او يعني بالماس تبعولها اذا كنا عم نحكي of balls of the same type اللي بصير انه هيدا البول بتيجي بتعمل كوليجن مع هالطابه وبترجع بنفس قيمه السبيد الاساسيه وانما بالاتجاه المعاكس which is quite يعني logic اما بالنسبه للطابه الثانيه فهي انجا بتحرك لقدام يعني بتحرك بشكل كثير بسيط لا يذكر لانه هون نحن عندنا انه ال M1 over M2 is approximately equal to 0 it's not perfectly equal or strictly equal to 0 so this is it about the collisions what you need to know from this chapter is the definition of the linear momentum the conservation of linear momentum when you have an isolated system and you need to know what is a collision the type of the collision and how do you get the final speed of the particles after before and after the collision through the equations that we have seen in this section.